All right, number 49. Use the limit comparison test to determine if the series converges or diverges. Now, I don't like necessarily what I did right here. I should have put this compare with 1 over n in the solution. I should not have had this there because part of the skill involved here is knowing what to compare it with, and that's something you would have to consider, in the final exams that you're as exam 3, choosing what to compare it with. So I'm going to, pretend like that's not there and just show you that, as I've shown before for exam 3, that you look at the largest powers, you have n to the 1/2 on top, n to the 3/2 on bottom, and then those two reduce to 1 over n. So that's how you get the 1 over n. Actually, if you pick the right exponent for n, you don't really have to perform the limit comparison test. I did, but if you compare it, you're going to end up with something like this, to where you reach a finite and positive number. Obviously, if you do the wrong exponent, you're going to get either 0 or infinity, which does not lead you to the correct answer. But so really, as long as you pick the right comparison here, 1 over n, and 1 over n, I didn't write that in here, but 1 over n is a diverging p-series, and since our limit goes to a finite and positive number, that means our series will have the same result as what we compared it with. So if we're comparing it with a diverging p-series, our series diverges by the limit comparison test with 1 over n. Number 50, ratio test. So I rewrote this basically to just put the e to the 6n on the bottom. So you replace n with n plus 1, so 6. A lot of people make a mistake here of they would just write 6n plus 1 here, but actually it's 6 times n plus 1, so therefore it's 6n plus 6. So you have n plus 1 factorial over e to the 6n plus 6 multiplied by the reciprocal of the original function right here, because you're actually dividing by that series. So it's the reciprocal, e to the 6n over n factorial. N plus 1 factorial over n factorial just simplifies into n plus 1. We've seen this plenty of times before, but that's just because n plus 1 factorial is the same as saying n plus 1 times n factorial. And then you would cancel the n factorials, and there you have it. So what we have then is that leaves an n plus 1 on top and an e to the 6 on bottom. Well, that e to the 6 doesn't mean anything. That n on top guarantees we go to infinity, and therefore it diverges by the ratio test. It had to go to something less than 1. Let's look at 51. Another ratio test. So you replace n with n plus 1, so you have n plus 1 to the 8 over 8 to the n plus 1. Divide by the original series, so you multiply by the reciprocal. So it's times 8 to the n over n to the 8. This reduces and leaves an 8 on bottom. We've discussed this before, but these terms don't algebraically cancel. What's actually happening is that as you're going to infinity, your leading term, if this was expanded out, would be n to the 8 over n to the 8. And that's just going to go to 1 no matter what smaller terms you have below it. So it doesn't cancel via algebra. It's the limit going to infinity that makes it cancel to 1. So that cancels to 1. We're left with an 8 on bottom. So that goes to 1 over 8. 1 over 8 less than 1. We have converged by the ratio test. Root test. Root test is pretty easy. Just take the nth root of the series. And nth root just kills the n, and then you evaluate the limit. So if the limit of what's left there goes to something less than 1, you have converge. It's greater than 1, greater than or equal to 1, you have diverge. So what happens here is we have, you take the nth root of the n, you have ln over 7n plus 2. which is technically infinity over infinity. So you take L'Hopital's rule, and derivative ln of n is 1 over n. Derivative of 7n plus 2 is 7. And then now you put infinity in there, you're definitely going to get 0. Lesson 1, converges by root test. All right, so once again, here's another one where I sort of spoiled the fun. I don't know why I did this, but it would be, the reason why it's 3 halves, because you have n on top, and you have n to the 5 halves on bottom when you take the square root of it. So n over n to the 5 halves is the same as 1 over n to the 3 halves. We don't care about the coefficients. So 1 over n to the 3 halves, you see I did work it out, but actually you don't have to as long as you have the right comparison p-series to compare it with. All you have to do is look at that p-series without even doing the limit comparison test. But the limit comparison test worked. We got a real number, 6 over the square root of 6, which is just, I just stopped right there, but that actually equals the square root of 6. But 1 over n to the 3 halves is a converging p-series, so therefore that series would converge by LCT with 1 over n to the 3 halves. Integral test. Yeah, let's see what we got here. I don't think that I would put this on a final exam, which means you'll probably quit listening at this point, but that might have been good for exam 3, but well, you know, integration by parts is certainly something that's on the final. I'm just talking about not using a series result. So yeah, I'm not saying integration by parts is I'm eliminating that. No, I meant using integration by parts for something like this. But anyway, yeah, this isn't too bad. You work all this out by parts. It gets a little messy, but it's not. You only have to do one integration by parts, so it's not too complicated. So the key is, you know, do all the terms converge to something. Any term that goes to infinity or anything, this is that'll blow up here. So when you plug this in, you're going to have, let's see, what do you have? I did, you put b in there, and then I sort of skipped a step here. I did the L'Hopital's rule without saying I did. This is L'Hopital's rule right here, because you would have got negative 6 over x. And I have a 1. Yeah, it's 1. I'm sorry, not 6 over x. It is 1 over x. Because the derivative of 6x, which is 6, over 6x would make it 1 over x. So now I put the b in there. There's a negative in front. 3x squared is now 3b squared. That's going to go to 0 as b goes to infinity. That takes care of that. You put 1 in here, you get negative ln of 6 over, I have 6 cubed, which, I don't know, I don't think that's right. That should probably be 1 cubed. Well, anyway, come over here. Fortunately, we're not trying to get the exact answer here, but still, I'm tempted to put this in Maple and see what it produces. Sometimes Maple will give me the answer, sometimes it won't. It's too weird. Well, anyway, you evaluate this part, so this is key right here. You get this go to 0, so you have nothing left but real numbers. So that's enough to mean that the idea is that if the integral from 1 to infinity converges, the series will converge. So I'm kind of questioning, why do I have that 6 right there? I don't know. I might bring up Maple here and come back to that in a second. So anyway, convergence or divergence using alternating series test. Alternating series test is pretty simple to use. It's when you have to determine whether or not it's conditional or absolute convergence that can get a little tricky. Let's open up two of them here. I'll put this in here real quick. Well, my maple result doesn't quite match. Now, of course, maple answers can look different, but I paused the video so I could just kind of play around with calculations a little bit. One mistake I saw on here, but I'm not going to go back and worry about this too much because I know that I did not put this, having to use an integral test this complicated on the final. But anyway, I somehow dropped this negative 1/3. You know, you have uv minus integral of v du. I forgot the next. I should have had like a negative 1/3 out there to the outside. So, all right. Well, okay. Let's forget that. But the point is, the maple answer here shows you that it did converge to a real number value. So I didn't quite get the right real number value, but the answer is correct that it converged. That was the main thing I wanted to check, that I did not make a mistake where the answer should have been diverged. That was the important part. Alternating series, pretty straightforward here. So the limit goes to 0 and the terms are non-increasing, so it passes the alternating series test, so it converges. Converging absolute or conditionally or just flat out diverges. First thing, there's a couple different ways to do this, but I guess the first thing you can do is check the alternating series test, because if it fails that, the answers automatically diverge. If it passes that, that means it'll be one of the two converges. I've never seen one come across. I'm sure there might be, but I've never seen one where if it passed number 1, then it didn't make it through number 2. But so that limit being with a larger exponent in bottom than top going to infinity will guarantee it goes to 0. So that means we have one of the converges. So now what we have to do is look at the result without the negative and decide what, whatever series test you think applies here. And the best thing to use here is limit comparison test. And you would compare it with 1 over n, because it's n to the 8th divided by n to the 9th makes it 1 over n. So like I've said before, without even working that out, you pretty much can, I worked it out and I got a finite and positive number. So, but as long as you have the right thing you're comparing it with, 1 over n is a diverging p-series. So what I wrote here is that it converges by alternating series test, but then when you drop the negative 1, it diverges by LCT. So that is what's called conditional convergence. That means the series had to have the negative 1 in order to converge. So it was critical. An absolute convergence means it converges with negative 1 or without negative 1, which is what's happening on this next one. All right, so it makes it through the AST easily enough. So we have converging. Now we've eliminated diverge. So we're going to test this without the negative 1. This is another limit comparison test, but I would compare this with 1 over n to the 5/4. And I didn't even work the LCT out this time, like I was saying. As long as you pick the right thing, which I did, and 1 over n to the 5/4, that is a converging p-series. 5/4 is greater than 1. And so it converges with or without the negative 1, and that is called then absolute convergence, or converges absolutely. All right, Taylor polynomials. I think pretty much just plug and chug on these. I'm not going to go through every detail, but I didn't put the formula here, but you'd have the formula on your formula sheet for sure. So since we're converging, or the centers at 8, everything's going to be involving x minus 8. And we're starting with natural log of x, so we have to take 3 derivatives of natural log of x, which isn't too complicated. So you get 1 over x, and then negative 1 over x squared, and then 2 over x cubed. Then we have to plug in the appropriate values in there, as you can see I did right here. F of 8, I didn't write f of 8 there, but f of 8 would obviously just be ln of 8. No big deal there. So f prime of 8 would be 1 over 8. F double prime of 8 would be 1 over 64. And f triple prime, third derivative, would be 2 over 512, which would then reduce us to 1 over 256. Then so we put those values in there, and then, after we get past that first term here, we start dividing by the factorials. 2 factorial, 3 factorial, and I didn't show all the work here, but then it turns out being answer C. So obviously you can put your calculator to good use here. All right, number 59 is the interval of convergence for starting power series now. And so we have to do the ratio test for these. So I have x minus 9 to the n plus 1 over 9 plus 7 times n plus 1 multiplied by the reciprocal of the original function. So basically you have a 7n and a 7n, that'll go to 1 as n goes to infinity. And then this will reduce to x minus 9. So you have the absolute value of x minus 9. For that to converge, it will converge on the interval where the absolute value of x minus 9 is less than 1. Because that's what the ratio test has to be, less than 1, which turns this into a 3-piece inequality with negative 1 and 1. Add 9, you get x between 8 and 10. Now, I would not go by the results of this problem. I ought to go back and change this problem. I probably won't. But yeah, this is the only one that has 8 and 10. But I would assume on an exam that it's not going to be like that. You'll have this last answer should have also been like something with an 8 and a 10 and different symbols here. So I wouldn't plan on getting lucky and being able to do that. So let's pretend like there was more than one answer choice there. So let's see why A is correct, other than just the fact it's the only one that has 8 and 10. So we check the endpoints, put 8 in there into the original series. So the numerator, you have 8 minus 9 gives you negative 1 to the n over 9 plus 7n. So that's just when the negative 1 to the n there means you have an alternating series. So we have converge by alternating series test. So we definitely have a closed endpoint at 8. Let's check 10. You put 10 in there. 10 minus 9 is 1 to the n. 1 to the n is just 1. And then this one, several ways you can get diverge here, interval test, but the easiest way would be diverges by LCT with 1 over n. So you have it converging at 8, diverging at 10. So that is why this is the exact correct answer, to have the equal at 8, but then not having the equal at touching at 10. All right, so it's important to understand why that's the way that was. Here's a radius of convergence problem. Let's see. I don't know if your test will say k or not, but you can obviously change that k to n with no harm. So we have x minus 7 to the k plus 1 over 4 to the k plus 1. And times the reciprocal. So let's see what happens here. K to the 5th, k plus 1 to the 5th. That'll reduce to 1. 4k or 4k plus 1 will actually have a 4 on bottom, which is right here. And then the x minus 7 to the k plus 1 over x minus 7 to the k will leave x minus 7 on top. So you have x minus 7 over 4 has to be less than 1. Bring the 4 up and over. And once you don't have the denominator there, once that's gone from 4, it comes over here, that is your radius of convergence. Now you could work this out further, and you could also figure it out by, setting up the -1 and all that stuff. You'll get, let's see, what you'll get 11 here, and 3 here, and the center is 7, so the radius is actually the distance from 7 to either end. 3 or 11 would be 4. But actually, once you clear that denominator out and bring it up and over, that will be your radius of convergence. Assuming we're not talking about where it's 0 or infinity. This means if it's something that's not 0 or infinity. 0 occurs only when you have convergence at a single point, and infinity is going to be where you have convergence for all real numbers. And okay, so that takes care of that.